Hello everyone. After pre-training is what the most important steps comes which makes the LLM what it is right now. There is a big pre-training pipeline which we have already seen, but there is an even bigger pipeline which is the post pre-training pipeline, which involves methods like SFT, pre-training alignment, tool integration, context lengthening, evaluation of those, and many more. We are going to see about all of those in detail in this video. This is a sample post pre-training pipeline which is followed in one of the best LLMs which is there in the market right now, which is none other than the Llama 3 model. What happens is, given a pre-training model, first it will be trained on a supervised fine-tuning data which is known as instruction tuning, where the idea is to train the model to make it follow the instruction given by the user, and that model will be aligned to preferences, and the model which showed the best result will be considered, where what happens is will have a set of prompts for it to optimize itself. Okay, so this will be, let's say, a set which is collected via user feedback, and what we'll do is we'll use this model to generate k generations, which is k outputs for these prompts, like n outputs if you want to put it that way. And then we'll do a process known as rejection sampling with the help of preference model, which is reward model, and then we'll train again. So I know it will sound very confusing, all right, but you need not worry. We'll come back to this pipeline by the end of this video once again, and that time you'll be able to understand, okay, this is what it is all about. All right, now let's see about the post pre-training procedure. What is this post pre-training procedure all about? The post pre-training procedure involves refining a pre-trained language model to enhance its performance by alignment, safety concerns are addressed, and making it better for some applications alone. Okay, so you can just put it, alignment and perfect for specific application. So for that, what is the importance of this procedure? First, like I said, you do SFT, all right, that will align the model's behavior to your instruction. And also there are some human values, right, moral values. You can't speak a few things. So that kind of a control can be done with the help of a post-pre-training procedure mechanism, for example, the preference alignment mechanisms. So these are achieved in this post-pre-training procedure, and that is very important when you use it for real world. Next, to enhance capabilities like reasoning, coding and all, you need to do post-pre-training, okay? And then finally, the most important thing when you use AI is the safety concern. You can mitigate a lot of harmful outputs by implementing safety measures in this procedure. So that is why these procedures became very important, that people are now focusing more on post pre-training rather than pre-training, because already very good models are available pre-trained over the market, and people are now using those models to just pre-train their own, post pre-train, which is fine-tune their own. All right, now what are the alignment techniques? Because I told you here, right, aligns model with human values and instruction. How do you do that? So the purpose of this alignment is to align the model output, or ensure that the model output is aligned to human values and ethical standards. Okay, so that is the purpose, as the name suggests. But the methods here there are 3 methods, out of which 2 are very popular. One I didn't even know until I saw the research paper of Llama 3. The first one is SFT, which is supervised fine-tuning, or else commonly known as instruction tuning, where the method focuses on tailoring responses to follow human instructions accurately. Let's say I'm saying generate a story of 5 lines, then it should generate only 5 lines. Okay. Next, DPO and RLHF, 2 of the most sought after preference alignment methods, where it will incorporate direct and indirect human feedback. So why is that? There is a method known as RLAIF as well, where AI will provide feedback for which human feedbacks are used to train that model. But the thing is, when I say generate a story of 5 lines, it will follow my instructions exactly, but what kind of output it will generate? It can use bad words, it can use biased sentences, but we don't need that, right? So to make sure that the model doesn't do that, you use methods like DPO and RLHF, okay? Because this will provide reward when it generates correctly, and it will punish the model when it does things wrong, okay? That is why this is used for preference alignment, and these are all methods of reinforcement learning. Next, we red teaming, where the idea is that you should proactively identify and mitigate harmful behaviors. So there will be a team known as red team, where they'll try to purposely fail the model so that you proactively find it and mitigate the harmful behaviors by using techniques which are already there. The impact of this procedure is that it will produce a safer, more reliable, and a better model in every aspect. First, what is supervised fine-tuning? As I said, it will enhance the model's ability to follow instruction and perform specific tasks. So whatever tasks you say as an instruction, it will be able to do that. As far as the process goes, it will utilize labeled datasets tailored to desired tasks. So for example, if it is a coding task, right, you'll say something like generate me a code for, let's say, generating a prime number, something like that, okay? So it will try to have that as a generation. Basically, the output, whatever you have here as an expectation, right, that becomes your label. It's not like 1 or 2 is going to be a label like in a classification, but here the labels are going to be your output which you are expecting once the instruction is provided to the model. It can be a QA, it can be a task, let's say generation, whatever it is, whatever output you expect from the model, it is the label, okay? So that kind of a label data set is created. That is why it is supervised fine-tuning, okay? Because you are providing a supervision indirectly by saying this is the result I'm expecting out of you. All right. Next, we train the model on these data sets, which will improve the task specific performance. And also when you do instruction tuning, there will be a cross task performance improvement. So basically, let's say you're training the model for summarization as well as translation, okay? So to some extent, its performance on multilingual summarization will increase because translation gives its knowledge about the other languages, and also summarization will say about the task. So to some extent, it will generalize. The outcome of this step is that your model will be better aligned to user instruction, and it will provide higher accuracy in specific tasks. So as far as the detailed process, first step and the most important step here, like after this video, you will have a mini course coming up your way on how you can fine tune any LLM. And after that, you'll say like, okay, I need to do only dataset. Code is not a problem. Vasant has already provided me the code. Regardless of what model I'm going to use, it doesn't matter to me hereafter. That will be your thought. All right. So dataset preparation is more important. Data processing is more important than the training side. Okay. So make sure that you curate an instruction-based dataset covering various tasks. An example could be FLAN T5's data, which is FLAN, OpenMS, and there are many datasets. If you are using multilingual, there is XP3 for multimodal, there is M4 Instruct, and many more, but these are all examples of instruction datasets. And then you have a thing which you need to ensure, okay, which is diversity. You should not be saying monotonically, let's say, do this, do that. It should be more like a human conversation. That is when it will try to understand, okay, so I need to understand the instruction. So always giving a instruction template, let's say, classify the sentiment. Okay, that doesn't work when you do SFT. Okay, so make sure that you have a variety of tasks and variety of instruction for each task. Okay, That should be more like a real world where, like the instruction and the sample should not feel so different, like it should coerce with each other. It should be like a real conversation which you are asking to a chatbot. When you are creating an SFT dataset, right, the best way to create a dataset is to imagine you are talking to a chatbot. That would be the best way for you to create an SFT dataset. As far as the training protocol is concerned, you will have the pre-trained model being fine-tuned on these datasets, and you are having a supervised objective where you'll use cross-entropy loss to minimize the instruction following error. As far as the evaluation metrics are concerned, we'll see how much the response is relevant to the like target we have. Task accuracy is there, instruction adherence is there, but those are theoretical things. Practically, the metrics are very different, which we'll see later. So now that you have an idea of SFT, now let's see about DPO. DPO is a technique where models are trained based on direct user preferences. What is that? So let's say I'm asking it to do a summarization, right? Summarization, it depends on, like each one's understanding and how each one expresses their understanding. Okay, summarization is one where personalization has a lot of things to play with. For example, QA doesn't have a lot of personalization. For one question, there can be only one answer given a context is provided. Right? See, the way you express that could be different, right? But the answer is same. But still, the way you express the answer, some people might find abrupt answer. Let's say, what is direct preference optimization? It is a technique to do preference alignment. Some people might expect that kind of a response. Some people might expect a detailed response where you will get everything. So aligning to each of the users' preferences, for that you can use this technique where what you will do is the process involves you to collect preference data set from users or evaluators. So given a question, we'll try to collect, let's say you'll have a response. You'll also generate a few responses from your model itself with different parameter settings, different, let's say, prompts being optimized, let's put it that way, so that you get different output. So you will ask the evaluator, which user, which response do you prefer? If you see in ChatGPT itself, right, it will ask which of these two responses do you like? Basically, they're using that data to train the model. Okay, that is what is happening behind the scenes. So that is the process. So now what we'll do is we'll use this data set to optimize the model to produce these outputs where the user gave a thumbs up, let's say, rather than a model providing thumbs down. Okay, so model will be now forced to generate a thumbs up response rather than a thumbs down response. Make sure this, in DPO, it's not about making it generate the correct answer. Okay, that is something you need to do with SFT. In DPO, it's about, there are many ways to say a correct answer. You want it to answer it in a certain way. For example, it is not like, I can't use a bad word and then say the answer correctly, right? There is a lot of ways I can say, but not choosing to use bad word is a preference. Okay, so that is why it is direct preference optimization, and for this it will use a loss function known as DPO loss. It is a very highly theoretical concept, let's put it to that way. If you want the theory of direct preference optimization, the links will be in the description. Videos are already uploaded on theory of direct preference optimization and LoRa, which will be two concepts which we'll widely use hereafter in this LLM mastery course. So make sure that you watch those to understand how these two work theoretically. Okay. As far as the advantages goes, it will directly incorporate user feedback, and it will enhance the response being relevant to the user and satisfying the user. So how will you collect the preference data? Either you can gather user preferences like how ChatGPT does, or hire some evaluators, get their preferences. That is one other option. Or else you can do surveys, and then based on that also you can get it. Or else take your AI, put it in a beta testing, give some people's access, collect their preferences. That can be data for you as far as the preference data is concerned. Or if you have a general alignment, let's say you want your model to say no harmful things and all. For that and all, there are common data sets like HHR, LHF, which are open source data set. You can use that. Okay, it depends on the task. And as far as the training loop is concerned, we know it is just to integrate this preference data into the training loop, and you will be optimizing your model to prioritize preferred responses. But there will be a very important stage, which is model retraining, where what you will do is you will repeat this process again after a deployment. Okay, these are prior to deployment. After deployment, this process of aligning to the preferences will be repeated, how ChatGPT does right now. But there was another method before to DPO actually. Okay, this is what is powering ChatGPT. Let's put it that way. Okay, ChatGPT is doing very good, and one of the reason for that is RLHF, where what it will do is it will combine the reinforcement learning methods with the human evaluation to refine the model output. It might sound confusing, but to put it simply, in DPO you will use the ground truth as the preferences as yes or no, which is a binary preference from the user. Okay, but here what you'll do is, based on those preferences, basically what we'll do is we'll train a reward model. For that, first you need to generate multiple responses for a given prompt. You will use human evaluators to rank these responses, not just two. In DPO it will be two, okay, binary, but with RLHF it will be multiple, okay, 1 2 3 4 5. And now we'll train a model just to provide these rankings. Okay, so given a prompt and a response, it will try to say, okay, this is the reward for this. And now what you will do is, this reward model will be used to fine-tune the language model, where for providing rewards and punishment, this model will be used rather than a binary label from the user directly. Okay, that is what is RLHF, and the benefit here is it will align model behavior with human preferences. That is the same as DPO. The only thing is this is more flexible, that is more rigid. This is harder to do, that is easier to do, but mostly research papers have shown that DPO is slightly better, very slightly better. But if you have large amounts of data, RLHF is a better method. Let's put it that way. Now, next process is reteaming and safety mitigations. Obviously, when you talk about AI, security concerns come into the picture as soon as possible. The definition of reteaming is that you will simulate adversarial attacks to identify, mitigate the potential vulnerabilities. In every big companies, they'll have a team known as red team, where their idea is to find issues in your product. Okay, so the process involves deploying internal teams to test the model against various threat scenarios, so that you can identify biases, misinformations, and harmful outputs. Right? If you have heard about things like bug bounting, okay, that is a form of red team. Here the safety mitigations will be implementing filters and constraints based on their reports, and then you'll be continuously monitoring and updating your model with the help of the techniques which we said before, with the help of the red teaming's findings. And one of the most important capability provided to LLMs right now is to integrate itself with tools. So given a tool, it should be able to call the tool, so that it can be widening up its scope. Basically, if it doesn't know about stock information, it can call a function which will provide the relevant stock information, so that it can answer directly. Okay, this can be web RAG and many more. Everything can be converted into tool, and for that the model should be trained in such a way that the model should recognize and utilize these tools contextually. Okay, so that is very, very important, where you will develop an interface for the model to use external tools and API. So here the model is expected to recognize and utilize these tools correctly. For example, using database queries for information retrieval, code compilation, debugging tools in things like Devin or OpenDevin. Okay, so these are some examples, and the benefit is that you are effectively expanding the model's functional scope, and also you can automate a lot of complex tasks. Next, probably one of the most important aspects nowadays, as consider it to be a parameter in the competition of AI, which is how much context length that can the model handle. Because if you see, even with RAG, there is a inherent issue of out of context. Okay, the LLMs have great capability to understand and reason, but it can't go beyond some extent sometime before. Okay, but nowadays the architecturally there have been made some advancements such that it can handle a larger context window. Context window is nothing but how long the LLM can see and understand with very, very little loss in attention. Okay, so let's say if I see 100 tokens, I'm doing good. 200 tokens, I'm doing bad. Okay, so somewhere between 100 to 200 is my attention span. So that attention span is your context length. Okay, how much context length it can efficiently process. The challenge is here is that it should maintain coherence over extended dialogue. So if it is generating, on and on, like a movie script, like how I'm boring you all right now with this video, here that is also a challenge for me, right? Maintaining the coherence of what I'm speaking. So I need to remember what I spoke before. I need to remember what I need to speak after. At the same time, I need to make sure that my sentences are coherent enough so that you don't feel that I'm just a idiot. Next, memory management is very important, because larger the memory you are holding in your GPU, it will improve, increase your memory. So there is a possibility for you to go code out of memory. You need to handle that as well efficiently. The solutions are that you need to make architectural adjustments to handle large context window. Some of the examples are rope as far as the positional information is concerned. For attention, you can use grouped query attention to reduce the computational overhead. For sliding, you can use sliding window, which will reduce the overhead, and also it will extend the context length to a wide range. So you can use those kind of mechanisms. And these kind of solutions are already taught in previous days, where I've said about architectural advancements in positional encoding and attention. So if you haven't checked it out, please check it out. It is already available in the channel. The application of this context lengthening is to have long form content generation, and you can do document analysis, anything which is long in nature. Next, what are the optimization strategies you need to do which will maximize your efficiency? First, you'll do parallelism while training. That is 4D. What are the dimensions? First, tensor parallelism, then pipeline parallelism, then there is context parallelism, and then data parallelism. Okay, all of these can be done for efficient training. Quantization can be done for inferencing with a reduced model size, accelerated inference, but very, very small loss in accuracy. That is why this GGUF format got famous, and we are using Ulama, things like that, which are all using quantized model at the behind the scenes. Memory management is very important, where you do KV caching, optimizing attention mechanisms. Those all come under memory management. As a result of these kind of optimization technique, you will have faster training and inference time and reduced memory computation overhead. Evaluation and benchmark, so that is usually used to measure your success. I'm a person who believes LLM creation should be eval driven. Okay, and I have made a separate video already, which I'll put it soon. Okay, that was an old video I made, but still theoretically it is very relevant. So I'll upload that video very soon, and you can also check it out. Finally, the challenges and solutions. Some of the challenges is, like I said, managing computational resources, data quality ensuring, and complex behavior. For that, your model should be aligned. So for these, what can we do? First, for this computation issues, like I said, you need to parallelize your training at data level, at model level, at tensor level and all. And then optimization needs to be done in the architecture. As far as the data quality ensuring, your curation should be very rigorous. Focus more on seeing for variety of resources rather than the same source, and make sure that you have a QC team to check, the data is good or not, taking some samples out of the data set. And then iterative alignment will align the model to complex behavior, where you'll use human feedback and red teaming. Now, when you see this statement, you all now know what is DPO, what is SFT and all. Now see this architecture. This pipeline starts here basically. Okay. So what happens is you'll have an instruction data. You'll train your model with that instruction data, and also you will have some other synthetic generated SFT data. Okay, so this is where the pipeline starts. You'll do your SFT model, and then with some data available for DPO, you'll do a DPO training, and the best model you get out of this round. So this will become one round to start with. Okay, because at the first round you won't have these things with you. Okay, so for DPO here, if you see the data is already there, you'll have a preference data to start with, and simultaneously when you're doing DPO, you will also do a reward model training. If you all remember that reward model training, okay, where now what you will do is rather than an RLHF, you'll do something very different. You will get the best model from the previous round. You will have some prompts collected. Maybe it is from user, or is it from a different source where the model would have not seen the data. And now you will ask your previous model. Let's say you are training it for 10 iterations. The first iteration model will be asked to generate, let's say, 10 responses. And here the reward model will reject the sample responses which it thinks is not good. Okay. So basically this is a filtering process. It's not providing reward, but indirectly it is doing filtering, saying like, these are very shit responses. Try to adapt yourself to say this response. Okay. It's like, you are doing multi-epoch training, but at each epoch for each question, the answer might be different. Okay. Now you will sample those responses. Your SFT data is now ready, which is instruction in response. Again, you will have the synthetic data. You will train it again. So this process will repeat. Okay, this is how Llama 3 has been trained, with involving a loop of rejection sampling, supervised fine-tuning, and direct preference optimization. And for context lengthening, you can use processes like annealing. Okay, and that is how you do post pre-training, where you need to focus on a lot of things, and a lot of things are coming up in the channel. So if you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. Let me know your thoughts in the comment section as well. Are you liking these kind of videos? I'll see you all in another video. Until then, happy learning.